Welcome to an example about a negative iron sports bracelet. It claims to increase athletic performance. To test the bracelet, 8 runners are asked to run a mile wearing the bracelet. Their times without the bracelet, minutes, are compared to their times using the bracelet, shown below. So this is runner number 1 right here. And then runner 2, runner 3, runner 4, runner 5, runner 6, runner 7, and runner 8. So runner 1 gets runs without the bracelet, no bracelet, and runs in 7.4 minutes. But then when he or she runs with the bracelet, does a little better, a little lower time, does a mile in 7.2 minutes. Runner 2 does better, 9.9 is a little better than 10.1 with the bracelet. Runner 3 does a little better with the bracelet. Runner 4 does worse with the bracelet. Takes them longer. Runner 5 does the same either way. Runner 6 does better with the bracelet, a little better. Runner 7 does a little better time, a little lower time with the bracelet, 9 minutes instead of 9.2. And finally, runner 8 does worse with the bracelet. Okay, so is the bracelet making a difference? This was our test. Now this, we need to notice that this is a dependent test. It's not two independent groups, it's dependent. Why? Because these numbers in this row and the numbers in that row, they're dependent on one another, meaning they're the same person, like the 7.4 and 7.2 here, or the 7.9 and the 8.5. Those are the same person. So they're dependent, they're connected. Now, they could have set this whole question up differently. They could have said, look, we're going to have 10 people run without the bracelet, and then a different, or 8 people or whatever. I'll just say 8. So they could have 8 people run without with no bracelet, and then a different 8 people run with the bracelet. You know, like 16 people altogether, 8 run with no bracelet, and then a different 8 people run with the bracelet. We could have compared those. That would have been independent. Those would have been 2 separate independent groups, and we would be choosing the calculator tools for independent. But that's not as good as what we're doing. We're doing dependent, because if you did 2 independent groups, like, and the group that wore the bracelet ran better, then you would think, well, maybe the bracelet made a difference, but maybe those 8 people that, they're different than the other group. Maybe they're just faster runners. Whereas the way we did it, it's the same people. It's dependent because it's the same people, right? The same 8 people ran with no bracelet and then with a bracelet. So you don't need to worry that this is a faster group or slower group or whatever. So, but it makes it a dependent sample because these numbers and these numbers are connected. They're the same exact people. They're dependent on one another. They're not independent like we often do. So we're going to go to the calculator and choose dependent. So we have to grab these numbers and paste them in. Let me show you about that. First off, what calculator? Let me go back and write that. It's calculator number 20. Calculator number 20, the dependent one. So let's go back and take a look at that. Here it is. So down there, number 20, 2 dependent samples with data. So choose that. And when you do, you'll see this calculator here, 2 dependent samples with data calculator. I already pasted in data group 1. You can see it up there in the top. Let me do great data group 2 just so you can see what it's like to actually do that. So I'll come in here. There it is. Do data group 2. Here we go. Copy that. So I just highlight it, copy it, and then go to the calculator. Gonna paste it in right here. Here it is. Now we got to put commas between them. So erase those spaces and put in commas. There we go. Now we've got to choose the confidence. So let's go back. Let's see. Whoops, let's see the question. See what the confidence level is. They want confidence level 85%. 85%. Oh, by the way, let me just get the answers for us right here, right now. So there's the 2 answers we're looking for, negative 0.19 to 0.17. So you see the confidence level is 85%. Let me show it on this screen where you can see it really clearly, right here. Right here. 85% confidence level. So there it is. That's what we're going to need to put into the calculator. 85% confidence level. So 0.85 or just 0.85 either way. I don't care about the greater than, less than at all. That's only for hypothesis. Hit calculate, and I'm looking at the lower bound, upper bound numbers. So here, let me bring that over and show you. Paste it in here for us. 1, 2. Okay. Yeah, so our answers are right here. Lower bound, upper bound. Negative 0.19, so negative 0.1917 and 0.1667. That's our confidence interval right there, those two numbers. So negative 0.19 and 0.1667. Is that the answer we saw before? Double check. Yep, so that's the same answer. Good. All right, so back to it. So there's our answer. So we come on down here. This would be confidence interval. What were they? Negative 0.19, comma. This one, 2 decimals, 0.17. Well, that'll round to 0.17, 2 decimal places, right? Right, see how I rounded these numbers is negative 0.19. You're going to go two. You're going to stop after 2 places, stop after 2. But if this is a 6, that'll round it up. 0.17, huh? So negative 0.19 to 0.17. Negative 0.19 to 0.17. Put parentheses around it. That's the confidence interval. Now, what does that mean about, according to your confidence interval, does the bracelet improve run times? Well, what does this say? Well, to answer that, you got to notice that we got a negative number and a positive number. If you come back to the notes, here we go. This is the notes right here from class. See number 4 right here, meaning of a confidence interval for 2 groups. If you have, it says right here, if you have all negative, 0 is not included, that means mu1 is less than mu2. If you have all positive, 0 not included, that means mu1 is greater than mu2. If you have a negative and a positive, that's us. That's our situation right now. A negative and a positive, right? Some negative, some positive. Then what does that mean? That means 0 is included. So it might equal 0. Thus, they might be equal. So we have no confidence that they're different. They might be the same. We have no confidence that they're different. No confidence that they're different. It's inconclusive, in other words. We have no confidence, right? Because we're saying, well, why are we saying that? We're saying we took the difference between 2 numbers, and that difference could be negative, or it could be positive, or anywhere in between. It even could be 0, right? If I said, hey guys, I'm subtracting 2 numbers and the answer comes out positive, like, what does that mean? Well, that means the first number is bigger. Tracking with me on this, right? Like 10 minus 7 is positive 3. The first number is bigger. So if you get a positive answer, but if you're subtracting 2 numbers and you get a negative answer, right? If you go a minus b and you get negative, that might be like 2 minus 8 or something, you get negative 6. The first is smaller. First number is smaller if you get a negative answer. Now, what if you get 0? What if you go, well, I took a minus b and I got 0? Well, that means they're the same. That'd be like 7 minus 7 is 0. They're the same. So my point in our situation is we got an answer that was somewhere between negative and positive. What was our answer? It was, yeah, right there. It was negative 0.19 plus positive 10. So we're saying the A minus the B, meaning the no bracelet minus the with bracelet group. So the no bracelet minus the bracelet group. That difference, that's the A minus the B, that difference came out what? Somewhere between negative 0.19 and positive 0.17. So it could be negative, it could be 0, it could be positive. We just know the answer came out somewhere between negative 0.19 and 0.17, like on a number line. Here's 0, here's negative 0.19, here's positive 0.17. They're just saying the answer came out somewhere in that interval between negative 0.19 and 0.17. So the answer could be negative, it could be 0, or it could be positive. The difference between the true, meaning for all people, you might wonder, why are we not sure? Well, this is just a sample of 8 people. We're saying, what does this tell us about all people? All people who will ever run with no bracelet versus run with a bracelet, will there really be a difference? Well, we're 85% sure that if you take everybody in the world and have them run with no bracelet and then with a bracelet, and you take the difference between their times, that difference will be, we're 85% confident that the difference for everybody will be somewhere between negative 0.19 and positive 0.17, which means it could be negative, could be positive, could be 0. So we just don't know. We just don't know. So our answer is right here. At 85%, our data is inconclusive. We cannot estimate the effect of wearing the bracelet. It's inconclusive. We just don't know if it's negative, positive, or 0. What the true difference is going to be between, for all people that ever use the bracelet. We just don't know from the data we got anyway, from the times of the runners we got here. It's just too wishy-washy. They're too close. We just can't tell if the bracelet's working or not, because our confidence interval, we're 85% sure that the real average for everybody who tries to use the bracelet, the difference between their bracelet times and no bracelet times, will be somewhere between negative 0.19 and positive 0.17. So it could be negative, could be positive, could be 0 difference. So we just don't know. It's inconclusive. And so there we go. That's how we do that.